Hi guys, and welcome to today's lesson. We're going to kick things off with a warm-up, which is more fractions. We're going to keep practicing fractions until we feel pretty good about them. So go ahead and find the product of all of these different fractions. You can work with your partner or you can go by yourself. Right now the video is going to pause. When it plays again, you'll be able to see all the answers. If you have any questions, mark them, and I'll go over them with you next time I see you. All right, go ahead. And here are your answers. So you'll notice as we go through these, whenever I was turning the mixed numbers into improper, or the mixed fractions into improper fractions, you can kind of see me writing the multiplication symbol and the addition symbol. So if you've forgotten how to turn a mixed fraction into an improper fraction, you're going to multiply the denominator times the whole number and add it to the numerator. Also in red, you can see where I cross simplified, which is something we discussed back on like the first day of class. But again, if you have any questions specifically on this, please come ask me and we'll go over these problems when I see you next. But for now, let's go ahead and get started with the lesson. So today we are going to cover a few topics. We're going to start with property of numbers, and then we're going to go all the way to solving equations. Okay, so we got a few things to cover, but it'll be fine. All right, let's start with property of numbers. Now, properties of numbers, these are going to be your inequality and multiplication, identities, all sorts of things. These are your rules. Now, most of these rules are going to fall into the no duh category of life, as in no duh, Miss Stockton, that's obvious. Regardless, here they are. It's always a good idea to know why you're doing something, okay? We got to be able to explain this. So reflexive property is going to be anything is equal to itself. Now this is a number plus equals a number, or it can be an expression equals an expression. This is going to be helpful later when we start substituting things. Symmetric property says that things change along the equal sign. As you can see right here is our equal sign. On the left side there's an 8. On the right side there's an expression. Notice how in the second half of the sentence equal sign and the expression and the number 8 have flipped. Okay, so symmetric allows things to change across the equal sign. Now, transitive property, you can kind of put this into simpler phrases by saying A equals B, B equals C, then A equals C. Okay, there's a lot of things that are equal to each other. And so if you've got two expressions that are equal to each other and one expression is equal to a number, as is this example over here, eventually you can start connecting facts and equations and expressions and noticing that they're equal to each other. And last but not least, substitutive property, we can replace things. We use this one a lot. So if you're told that n or x is equal to a number, and then you're told that you have n times 4, well, you already know what n equals, and so you can just substitute n for the value of the variable, which is what gives you 4 times 11. Now, again, these are properties you've probably already gone over, so write the word, write the example, give a few sentences in your own words if you want to explain it. But right now, we just want to know what these are so that we can know why we're doing certain things. Here are some more rules. Again, this is just why we're allowed to do stuff. So the additive identity, okay, identity, it's yourself. It's identical to you. So when you add 0 to any number, you're going to get a number identical to the first one. 2 plus 0 equals 2. 5 plus 0 equals 5. That is the additive identity. The additive inverse is when you basically add the negative. So 3 plus negative 3 equals 0. 4 plus negative 4 equals 0. 4 minus 4 equals 0. Okay, the additive inverse is when you add two numbers together and get 0. And these will be, by rule, the inverse of each other. Multiplicative identity, same thing. You want to have your answer be identical to the first number you started with. So 14 times 1 will give you 14. 15 times 1 will give you 15. Okay, so with the identity ones, whether it's additive or multiplicative, you want your answer to be the same number you started with. Now, multiplicative property of 0, It's a fancy way of saying anything times 0 is 0. And last but not least, the multiplicative inverse. This is, I don't know what happened to my words. Nope, it's just gone. Okay, the multiplicative inverse is when you multiply something by its inverse. So you may have noticed in the additive inverse, it was 3 plus negative 3. Well, the multiplicative inverse is going to be fractions. So let's go with a 2 times, well, what's the fraction part of a 2? Well, it's going to be 1/2. And this is going to equal 1. So you're multiplying it by its fraction variation, or its inverse, to get 1. So if you go 3/5, you would multiply this by 5/3, and that would give you 1. So for multiplicative inverse, you want the answer to be 1. Now, the reason why we go over all those rules is because we are going to, for the next few problems, use those rules as we're solving. Again, the whole purpose of this is to explain why. Why are we allowed to do these things? That way we know what we're doing and we're not just making up rules. So we're going to evaluate the expression and name the property used in each step. And for the most part, these are going to be fairly obvious. What you do is what you say. There's one exception, and I'll point it out to you when we get there. But here we go. So in our first problem, in our first step, we start off with 4 minus 3, and we end up with 1. Okay? If you read this entire expression, 7 times 4 minus 3 minus 1 plus 5 times 1/5. Okay, the only thing changing from this statement to this statement is inside the parentheses. So the reason why we go from 4 minus 3 to 1, here's the weird one, the exception. This is actually substitution. I can hear you through the camera. Miss Stockton, we clearly subtracted. Yes, but no. Okay? Substitution is whenever you replace something with something else. So if n is equal to 5 and we have 4n, substitution would say we can replace the 5 with the variable. Okay, but we can also replace expressions with numbers. What I mean by this is what just happened. If I say 4 minus 3, okay, well 4 minus 3 is 1. Okay, I replace the expression of 4 minus 3 with the value of 1, and I put that 1 in the spot where the expression used to be. Addition, subtraction, multiplication, and division, those properties are used for when you're going across the equal sign because you're doing it to both sides. Here, I'll show you. All right, let's say we have x plus 2 is equal to 5. I'm making this up. If I wanted to get x all by itself, I would have to subtract 2 from both sides. Listen to what I just said. I'd have to subtract 2 from both sides. That's what you did. You subtracted. And so this would be the subtraction property because you subtracted from both sides of the equation. Whereas in our very first step up here, this is substitution because we only did it to one side of the equation. All right? So if ever you're replacing an expression with a value on one side of the equation, it's going to be substitution. All right, that's the weird one. Now let's just keep going. Next, I'm going to be doing this one. This is the next one that's being done. As you can see, it goes to a 7 down here. This is going to be the multiplicative identity. And you can see I am paraphrasing because these are a lot of words. Okay, paraphrase to your heart's content. Make sure, though, I know what you're saying. So go ahead and use my paraphrase, my shorthand. All right, let's keep going. Next, when I multiply over here, because order of operations says I have to multiply, I go to the next step. Well, 5 times 1/5, answer is 1. Okay, so whenever the answer is 1, that's going to be the multiplicative inverse, because the answer is 1. Okay, here we go. Let's keep going. Next, I have 7 minus 1, and that is being replaced with a 6. So that's going to be the fun one of substitution. And then last but not least, I have 6 plus 1, and that's going to be replaced with a 7. So again, we have substitution. Okay, if you haven't figured it out by now, substitution is going to be the main one we use on all of these problems, because it's whenever you are just simplifying on one side of the equal sign. All right, using your properties, go ahead and try to solve these two. Remember, what you're doing is you're trying to list the reason why we go from one step to the next. The video is going to pause. You'll see the answers for the first one, and then you'll see the answers for the second one. Good luck. And here are your answers for the first one. And I tried to show you exactly what had changed from each equation to the next, or from each expression to the next. All right, now for 1b. And there are the answers to 1b. Now this one, interestingly enough, only had one round of substitution, and then it had a lot of other properties. So there will be some problems where you use the different properties, and then there will be problems where all you do is substitute, because all you're doing is simplifying on one side of the expression. So just kind of remember these vocab words, remember these properties. You will be asked on a test or quiz to list them according to what's being done. All right, last few properties. Commutative and associative, okay? Commutative and associative are addition and multiplication properties only. They do not work for subtraction or division because these two properties allow you to change the order of things. This is what lets you to combine like terms across an equation. So in the commutative property, 4 plus 8 is the same as 8 plus 4, which is obvious, but if you apply to subtraction, if I have 4 minus 8, that is most certainly not the same thing as 8 minus 4. So commutative property lets you flip things around, and because it's addition and subtraction, or because it's addition and multiplication, it will always give you the exact same answer. The associative property deals with grouping symbols, namely parentheses. Okay, this is what allows you to add these two numbers and then add these two numbers together. So notice how in this first expression, all right, I have 3 plus 5 plus 7. If I were to add 3 plus 5 and then add that sum to 7, okay, well 3 plus 5 is 8 plus 7 is equal to 15. Whereas if I go over here and let's say I add 7 and 5 together first, okay, well this gives me 3 plus 12, which is still 15. And you can do the same thing with the multiplication ones. Whether you multiply 2 and 6 together first or 6 and 9 together first, it doesn't matter, though you'll still get the same product. Again, these are the rules that allow us to combine like terms across an equation. Now, on to probably the property you'll use the most and recognize it for what it is, distributive property. Distributive property is whenever you multiply a term, a number, a variable, anything really inside a parentheses. So this right here is all math speak. Knowing how to speak math is very useful. I'm going to zoom in actually on the part that I really want you to write down and notice. And zoom. Ha. So in this first little bit, we have A times the sum of B plus C. This is the same thing. If you were to distribute this, you would get AB plus AC. All right, and it works with the back too. If ever you're in the back, you have the sum of A plus C or B plus C times A. It doesn't matter that it's going the other direction. You can distribute into the parentheses, whether A is in the front or back. That second line just says that it works with the subtraction. Okay, you'll find out, especially in geometry, but you'll find out math is a giant game of Simon Says. Okay, you have to be told you're allowed to do something before you can do it. And so that second line is just saying it works for subtraction too, which we already knew that. Now hopefully something you knew, but maybe you didn't, is that distributive property can be used to make mental math easier. We don't often associate that with mental math, or maybe you do. If you do, congratulations. But let's say you have 7 times 49. I'm down here. 7 times 49 all by itself is a pretty big number to figure out. But if you break 49 into two different pieces, then you can distribute and make life a little easier. So let's break 49 up into 50 minus 1. Okay, 50 minus 1 is 49. So far we haven't changed the problem. We're sitting pretty. So 7 times 50, well, that's suddenly a number I can deal with. And then 7 times 1 is obvious. 7 times 50, 7 times 5 is 35, so it's going to be 350. 7 times 1 is 7. So you have your 7. Now you have 350 minus 7, and this subtraction problem is a lot easier than the original multiplication problem. So you can do this with mental math and help make things better in your head, which is a good trick because you will not be allowed a calculator on the quizzes or tests moving forward. But probably the most common usage that we do all the time in these problems is going to look like this. Okay, where you are multiplying a number or a variable into a set of parentheses. So the way this is going to work, I'm going to do the first 2 problems with you, and then you're going to do the next 2. So here we go. For 3a, 2 is in the back, but it doesn't matter. You're going to distribute to both the first and the last term. Make sure you go to both terms, otherwise this won't work. Now you have 2 times 8, this is going to be 16, plus 2 times 4n, 8n. Now remember, you can only combine like terms. Notice how the 16 and the 8n are not like terms. Okay, 16 is a constant, 8n is a variable term. They are not like terms, so that's as far as it goes. All right, let's go on to the next one. Now in 3b, we have a -6. Whenever you have a negative number outside your parentheses, be very careful that you take the negative sign with you. Okay, you are multiplying the negative to every single term. All right, it helps to draw arrows, even if you can do this in your head, especially when you have a negative symbol, because that way you remember to change the sign of all the internal terms. What I mean by that is this. So you have -6 times r, that's going to be -6r. -6 times 3g is going to be -18g. Notice the sign change. Take the sign with you. And last but not least, -6 times -t. A negative times a negative is a positive, so that's going to be plus 6t. Notice how we started out with 3 terms in our parentheses, and our answer still has 3 terms. Okay, you shouldn't ever lose a term when you're distributing, or gain a term for that matter. You should have the same number that you started with in your answer. All right, go ahead, try the next 2. The video is going to pause. When it plays again, you'll see the answer. And here are your answers. If you got anything wrong, make sure you double check your work for math errors. If you're still confused, make sure you ask me next time I see you. All right, now some vocabulary. I've already been using these vocabulary terms. Maybe you already knew them, maybe you didn't. If you didn't know them, here they are again. So, like terms are when you have the same variables with the same power, and that's a key one. Make sure you know that one. So in this expression down here, I have 6a squared plus a squared is equal to 2a. Okay, if I was simplifying this expression, I could add these 2 together to get a 7a squared. 2a is all by itself though. Okay, a squared and a are not like terms, so this would be as far as it goes. If you need help with this, think about the classifications here at school: freshman, sophomore, junior, senior. Okay, if we're putting people in groups to go anywhere, the seniors are going to get together, the juniors are going to get together, the freshmen and the sophomores. You're going to be in groups based on your class. Okay, you're not going to put a freshman up with the seniors or a senior down with the sophomores. Okay, so the people in the same classes or with the same amount of power are going to stay together, just like with variables. Now, simplest form is when the expression does not contain any more like terms or parentheses. You're always going to keep going until all parentheses are gone and nothing else can be combined. This includes fractions. You will always simplify your fractions. Always, every single time, because that falls under the like terms bit of this sentence. Now, another word we have is called coefficient. Hopefully you know what this is. If not, here we go. The coefficient is the numerical factor in front of the variable. Okay, so you can kind of see down here we have our little chart. And if you were to have 17x, the coefficient is the number in front of the x, so 17. 6ab, your coefficient is 6. Every single variable has a coefficient. Because even if there's nothing up front, there is always a 1. So every number is going to have a coefficient even if it's only 1. Now, equations versus expressions. You may have heard this, you may have not. We've been using expressions up until this point. And expressions have all had just a singular statement of terms. There's been no equal sign. And that's been the key thing. An equation is going to have an equal sign. You can solve for an answer on an equation. X will equal 2. X will equal 0. All right? Expressions are simplified. Equations are solved. All right? So you solve equations and you simplify or evaluate expressions. Now, the answers to expressions are usually written as solution sets. So in parentheses, or these bracket thingies. Now, x equals 5 is also good, but the brackets indicate a list. Okay, so if I have a list of numbers, I could use brackets, and I could have 3, 5, 10, 11. And this is the solution set. These are all the possible answers for whatever problem I was given. So there'll be some times where it just says solve, in which case you can leave it as x equals 5. But then there will be other problems where it says to leave your answers in a solution set or written as a solution set, and that means they want it within the brackets. Both mean the same thing, just a different way of writing stuff. All right. Now with this one, you're going to solve each equation and write your answer as a solution set. I'll solve the first and the last one with you. You're going to do A and B on your own. All right, so here we go. Now, whenever we start, we're going to always start with PEMDAS. So parentheses is first. And inside of parentheses, we have our exponent. So this is going to be 6 plus 25 minus 5 divided by 2. Still working in the parentheses, I'm going to deal with the 25 minus 5. 6 plus 20 divided by 2 is equal to P. All right, now do you see there's nothing left in the parentheses except for the 20? So since there's nothing else in there, I'm going to actually erase those parentheses and just leave the 20 there, because the parentheses are not doing anything anymore. Now, before we go from left to right, do not forget about your division. We got to do that division first. So this is going to be 6 plus 10 is equal to P, which means 16 is equal to P. All right, make sure when you're doing these things that you're paying very close attention to the order of operations. The division sign in this problem tries to sneak in there. There will be other things that also try to sneak in there. So make sure you're scanning the problem and going in the order of operations. Also, a bit of a note on organization. I didn't really do it well on this problem, but notice how all of my equal signs are kind of next to each other. They're in the same vein. Okay? When you're doing your own work, keep your work organized. And that way it's easy to read, easy to follow. There should be kind of a funnel going on with the equal signs more or less lined up. All right, you guys do A and B on your own. When the video plays again, you'll be able to see my work and the right answers. Good luck. All right, and here are the answers. Now, B out of both of these was the one that ended in no solution. So there will be problems where the variables cancel out and you get an answer that doesn't make any sense. 6 does not equal 7. It never has and it never will. If ever you get a problem like that where that just doesn't match up, it's going to be no solution. Now, it's this last one, and then we'll move on. So in this last one, we have a fraction. I know you guys all love fractions. So we're going to deal with the fraction first, and we're going to distribute inside the parentheses. So I have 5 minus 1/2 C minus, And I'm going to cross simplify here. I know we don't technically need to, but I want you guys to get into the practice of cross simplifying because it makes your life easier when you get to the hard numbers. So the way this works is I have 1/2 times 6. All right, well 6 is going to go to the numerator. So it's already over 1. I'm going to cross simplify this. The 2 and the 6 are going to cancel. The 2 is a 1. The 6 becomes a 3. So that when I multiply across, I get -3 over 1. So I'm going to take that. I'm going to come back to my original problem. And I'm going to put that -3 in here. Now I only have one fraction. Let's leave the fraction alone for right now, and let's just keep combining like terms. Okay, I have 5 and a -3. I can move that over, okay? So now I have -1/2 c plus 5 minus 3 is equal to 4. Now I'm going to simplify this, and I have -1/2 c plus 2 is equal to 4. Subtract from both sides. -1/2 c is equal to 2. All right, now we get to the fun part. As of right now, we have two options. Now, I know some of you are looking at this and going, I know what the answer is already. Congratulations and hold on. We're going to do this mathematically, so when you get to harder numbers, you know what you're doing. Right now, we have the fraction is being multiplied by a variable. So we could divide the fraction. That's an option. Or we could multiply the whole thing and get rid of the fraction. I like option B, although option A works too. We're going to do option B right now. So I'm going to rewrite this. Instead of it being like that, I'm going to rewrite this as -c over 2. So if you didn't catch what I did, I had -1/2 times c, and that's going to be the exact same thing as -c divided by 2. Because whenever you multiply a whole number, or in this case a variable, to a fraction, it goes to the numerator. Now I have a 2 in my denominator. So I'm going to multiply both sides of the equations by a -2. And what this is going to do is it's going to cancel out the 2 and the negative sign in the denominator on this half. And when I multiply it over here, all right, -2 times 2 is -4. And now I'm left with c is equal to -4. All right. And that's a good way to get rid of fractions. You can multiply the entire equation, both sides, by a number to get the fraction out of or to get the number out of the denominator. Key point on this topic though, you can only multiply by one number. So that's why we simplified first as far as we could. All right. Hopefully all of that was pretty simple. In which case, here are the more interesting type problems. Don't get scared off by the big numbers. Don't get scared off by the fractions. Just do them one step at a time. You may work with the person sitting next to you. When the video plays again, you're going to see the answers and the work. Good luck to you, and I'll see you next time. All right, so here are your answers. You can kind of pause and zoom in as you need them. This one's a little down here. There it is. So yes, these took a little bit of work, but hopefully as you did these, you got really used to distributing and really used to dealing with fractions, specifically cross-simplifying and getting rid of the denominator. All right, if you have any questions, make sure you star them and ask me when I see you next. Bye.